Hey, what's going on, fellas? Another day of work, of course, and I guess another stream. So at this moment, this time compared to yesterday, I have slept before, and I did a full night, which is why we might actually get some more work done today, and that's a good thing because if you because I still have like here the big schema from the last time. There might be some there's quite a bit to do. So, of course, as we said here, there's a today's objective is variables. We'll try to not finish at 6 p.m. this time, but to get thing done earlier. So variables. Let's get on that. So what's the what will we have to do for variables? So let's take oops my my screen slightly. Wait, let me just set up my. I forgot to set up the pen. Give me a minute. Should be that should be good. Perfect. So what we are going to do today is so variable. I'm not gonna explain what a variable is. You already know that if you're here. Otherwise, good luck. But yeah, so variables in Castagne, they tend to have a specific structure. That structure was to write var, the name of the variable. Then you put the type, parenthesis, equals value. So that doesn't sound super nice, of course, when you put it like this. So why is it like this? Because that's actually something we will be able to handle this time, which wasn't really handled before. So let's break it down. So of course, the name, you kinda need it, and the value, you do need a default value. I guess we could make up one, but at this moment you always need to have a default value. The equals just a good way to have it. But yeah, we got three parts that are a bit different. So there's the var here. So that's the variability of the variable, because we can because of course we got the regular variables. This one can change, and we also got const. Wait, no, that wasn't const, but for constant things we have define, which gets replaced, which used to get replaced directly into the code, through a constant. In this new Castagne, maybe these ones could be accessed somehow, not to change, but that's the new feature is gonna be to be able to access them later. And there's another type of variable, which is called internal. So internal variables, you don't need to put all of that. You just put internal and the name of the variable, and it actually just exposes a variable from inside the engine. This is done so that there's no conflict, because if you first of all, because if you remember, we have modules. So modules provide functions, but they also provide variables to make them work. A very good example of one such variable is the position. So you got the position inside of Castagne, but this variable could be accessed. You got every single one of the internal variables starts with an underscore, so that there's no name conflict. But the idea was, if you might want to try and access it for various reasons. So this is available. However, if you did put a variable with the same name as this one, the Castagne compiler will catch you before, so that you don't have a name collision, and therefore, in order to actually use them and expose them, you have to use internal, so that you were declaring to the engine that you know what you're doing. Therefore, I would get less requests for help later on. This is one. The second here is the type. The type of the variable, that's kind of self-explanatory, but in Castagne version 4, we got integer, and we got string, and we got boolean, which internally was just an integer. But yeah, the idea was you would use integer for pretty much everything, and string, it was usually for state names, or other things, parameters, I guess. So the idea here is that you with these, in this new engine, I'm gonna try to add more types which have semantic meaning, which means instead of being like, oh yeah, I need something that has this, you can have state as a type. That means that the compiler will actually say, oh yeah, this is you're trying to transition to something, but this is not a state, this is you need to put that as a proper variable, like that, which would allow more in-depth programming, because you could already hold the state name inside of a string variable, but this wasn't as first of all, this is not as fast, but this is also not this also could lead to mistakes. So this will be better, although this is not what we're going to do today. Today we're just gonna focus, by the way, on just variables and integers, because that's the only ones we have at the moment. So we might add string fairly fast enough to this. Same for int. Sometimes you add percentages, which where can I held on, you put it in per mil, which kind of works, kind of doesn't. You add angles, there's and all of this was represented by integers. Therefore, we're gonna have actually inside of it, we're gonna put additional variables for angles and decimal values. But yeah, that means we're gonna have an engine that's a lot more smarter on this side. But yeah, and the final part, this is always empty. So why even have it? Because that's actually meant for one of the next features that's gonna be super important. And this is variable metadata. We're not programming it today though. So today we're just leaving this empty, and we're gonna say, okay, yeah, handle it later. Because you see, in Castagne there's a lot of this human editing. It's not just, oh, I put a variable and I'm okay with it. You got many defines and stuff, which would help. For instance, one of these at first was the I don't remember the exact name, but move x speed or something, which would represent how much your guy moved forward every tick. So the idea is that at first you just put the variable in the code, but in Castagne's editor, I added what we called custom editors. Custom editors were just replacing your code window, and it just took all of these defines that were there, and it put them inside of a neat little box, here. So it's a move speed, and you got here with up and down, you could put the value you wanted. Then, so this is generic, that's the custom editor. But then, because it kind of got added, but was a bit tricky to use, even though it also worked with states and stuff, we got to the spec block, which was a bit different. because this was defined by a module, but allowed a lot more customization and gizmos. So instead of having that, you had categories and stuff like movement, and you got the the speed. You know, it's not the variable was still called the same and was still defined at the end of the day, but it displayed something else, and you still had that little value, and the value in real time was used for gizmos. So you had your character on screen, and you could have, and it showed his path. So the idea is to try to bring that to the next level, because in the end that's still kinda like a variables block. The idea is to be able to go further with that, both with the values and with actually allowing it to become more generic. And this will go through that variables block. So this will be very useful to make tools and stuff, and this allows you to add additional data. One example, MoveX speed, for instance, you could put a minimum. If you put minimum equals 0 and the maximum equals 100, that's not it's not something I especially recommend, but you know, just to give the example, if you put a minimum and maximum, maybe now you can have a slider, and therefore you can make these a lot easier to access. Now, of course, and having it be accessible to everyone would allow better interfaces. That's what I meant here when I said you need to think about the previous, about the next steps with the editor. That's why you also put a lot of thought into being able to parse stuff that's not completely done, not compile it, but parse it. Because at the end of the day, we might have these, we might have a state, and when it asks for the state, you got a drop down. That can also very much happen. But that's something we'll talk about as we go on. So, but yeah, for today, we're not gonna go that much further. Today, we're gonna just focus on writing this whole thing, being able to handle it. We're gonna use this as an actual name, you know, that to find the variables inside the variables block. We're not gonna handle them inside of regular blocks, just variables at the moment. Put that into our symbol table. So therefore, make a symbol table and allow it to initialize the memory. Well, this is today's objective, because once we got that, that's a lot simpler to do, well, anything else. Because at the moment we have hard-coded variables. That's how important they are. We can't even run the program without it. So this will make us less dependent on hard coding. Then it's gonna be functions, but you know, one by one. So let's get started. Let's get started with that. So the first thing we're gonna do is gonna go through the Lexa once again and extend it, because at the moment it doesn't have anything for that. He got word. If you remember, if you see here, that's a variable, that's a word, name, that's a word, integer, that's a word, there's a two parentheses, then there's equals, and there's value. So let's add some words here, like var, define. We got to equals. Equals as a symbol is already there, but we kind of don't have much. Well, let's just put argument, because we're gonna use variable, word. Actually, we can use the variable with the variable name. That's kind of always here. Same with the define. Put here for we're probably gonna want to make variable a bit more, bit better with variable mutability. Yeah, instead of having three types, we're gonna add mutability to the variable on top of that, but later. With the equal, so it's gonna be variable argument, and will be good. And variable metadata just after. Okay. So, because let's start by adding a test, because at least this part we can test pretty well. Let's just keep on the happy path for now, because while there's while we will be able we should be able to handle even when you have something that's messed up. At this moment, we want to focus on having it run first of all. Variable ball int. Let's go with that. You got this. Then you got a variable, which is gonna be called var name. And then it's gonna be argument 200. Oh, we forgot the type of the variable. Yeah, it's do we put type as a separate token or not? Let's do so instead of overloading the variable one with a hello. You're gonna have a type token. Maybe we'll be using it elsewhere. Maybe it's some specific words, you know. Yeah, int and then argument. That's gonna be all lex line. Of course, if we go back test this guy doesn't work. What does it find? Word, var, word, var name, word int, parenthesis open, parenthesis closed, equals word to. But yeah, so that doesn't even find things properly. Wait, so wait, no, that's the past thing, and he panicked. Instead of expecting, it panicked, which was because we used var and we reserved it. That's why. Because we got because what happens with the reserved words? Because we got oh yeah, that was we already passed the word and then it's here. Okay, perfect. Actually, yeah. So lex script, lex argument, lex branch line, lex line. That's all. So token. Well, so we got some specific tokens. You can see we got the second token. So let's just match with one of well. Oh yeah, let's continue with our second token. So we do need that. Actually, do we? Yeah, a single word. Yeah, it kind of works here. So we can't really. We are obligated to duplicate this word. Ah, So in this case, we got a second token. Yeah, and let's match it like in the other one. Oh wait. Yeah, no. Hmm. Yeah, we do want to put that reserved word list. Because if we got the second word, like we do this token and then the token after that is a word, that's not gonna be too fun here. Let's put the we match the second token. I mean, let's actually we just want we are sure it's a word. And at this point here, we're kind of matching everything here, so this is all variables. And yeah, okay, and then we get okay, so we don't need second again. No. Variable name. And because we know where we are actually, let's put a let's put it well, because that we know we got var or define or something here, so we just put it there for later use. Let's put actually this var or def. There no. Let's get all of these done right now, so that we already match them and we know where it is, but we will handle it a bit later. And if we have some type we don't find, we just handle it with a little to do. So variable name, then so text line token squared. So then from that, what would be cool? A little single error once again. Wait, did we put single error? Yeah, we did put single error inside of the what do you call it, compiler. So everybody should have access to that get single error, right? Right, no, it was in semantics. Well, in semantics, but yeah, let's so in the Lexa, maybe we can replace all of these with a little call. Oh, but this was because we also had the back to it. Do we love or yeah, well, let's keep on doing how we did here because there's a bit less boilerplate, even though it's yeah. No, it's I kind of like actually having the needed full. $17 of those. Just got format. And, yeah, so here just one parenthesis less. Just here. You could probably do that with a regex or something. What's the keyboard shortcut for that? Control N? No. Because if I could, if I didn't need to put my mouse everywhere, that would have been. That could have gone. It would go faster. I found another time. No, not that one. I need that one. Okay, cool. So now we got a single error. Does that still compile? One error, and it's yeah, it's on here. So also 45 here, like here. Because we didn't still finish that whole thing. Got that format. I know it's not the best here, but I just keep all format. Okay, thank. Okay, so now we got the variable name. Perfect. So now it's time to get the type. Yeah, let's make another helper function. It gives us a token type, an option of token type. I don't know if it's gonna be useful, but I will put it here because it makes reading much easier. You know, kind of like here, like I need a yeah. That's kind of a. I mean, we're kind of expecting a specific token here, and we're not getting that token, so yeah. So could get share option, and instead of getting a token type here, we can get a string directly, password token, and we get here as a of type option a token type, and we'll get back the string if we get a word token. Because here, you know, like what do we even need that for? Let's put an error message. Actually, just if we are passing a word token, we do expect that to be a word token, so we put result between string and compiler error. That way we can return it immediately if we don't have that. Same here. Oh, it's not token type, it's lex line token. I mean that does mean we get like all the ones we still didn't put, so yeah, this should be allow us to do that a bit better. So let's see. It's a string. So for instance, here I don't need to put all of that. I can just change my column by state name equals was password token. Iterator.next. Yeah, I'm gonna put we're gonna make the error messages better with time, but at the moment that's and you put here, and here we put the interrogation point so that it's back there. Oh, here, of course, we match with the token we got. If the token is not, we send back an error. Send back a single error function we love so much with a format. If we got our sub token, we match again, I guess, that token. And if it's got, wait, no. Ah, yeah, we already got some, and now it's, we got a lexline token, and if it's a word, then we return that word. Otherwise, okay, now, first of all, we do need to check for if it's a reserved word or not. Do we check for reserved words? Yeah, we do need to check for reserved words, because in the case that it's a word and we actually want to get this, we have this as another thing. Here I'm expecting well, let's actually do it in two ways. Check That way we have access to this one if we need to. Yeah, because here we do have it, so it's not an issue. But just in case, there's no need to create a new one. So we send the one, and in any other case, we send back. So, and with this, we got our password token check, which will make all of these a lot easier on us. So that means we can't use a key. So we even got the fact that now we can't use a reserved keyword as a state name, which is extremely nice. Yeah. So in this case, we're missing the name of this. Right? So let's just replace all of this with let variable name. Yeah. We can also add another helper function, this time for, when we expect a specific token, but it's not. I mean, it's not the worst. But that's still always a good thing, so. I think these can go outside of it because they're just helper functions that we're using right now. To be used only in this script. Expect. Because here performance is not so, we're not on a critical path. Of course we don't want to have bad performance, but it's not critical for performance to not be as strong here. So let's get this expect token. So we're gonna use that same structure, match to the token. And if it's none, we put single error. It's good. If it's some token, then we match again on that token. The idea anything if t is equal to expected, we send back t. I don't know if that works, but yeah, well, I think that's how it goes. And in any other case, we also we should probably put a toString on that one. I think that could just be an if, but instead of this, let's see if it works that way we are. Yeah. Of course, it doesn't compile because that's how it works. Okay, so we're not in Lex script anymore. That's one thing. No implementation of. Can we do it like so? Yeah, that works. Okay, we need to clone this in. Because of here we already got I think the wrong place. This. Look, is there from string. Oh yeah, in the helper function. Where's it? That should work. Yeah, and we only got this one not working. So we still put tokens at the other line. That means we didn't pass it completely yet. Yeah. No, he didn't actually. Oh, he panicked here. It's better on the line, but still on tokens. Yeah, that's a end. Yeah. From this, first of all, we can put it with expect token, which is with the put that format here. This makes it a lot easier, as you can see. Like it's clearer to see what we're actually doing each time. And we see it didn't break anything, so that's good. So here we got a variable day. Perfect. Then we're gonna have to pass the type. It's time for the pass type function. Well, let's finish this. Pass type of this fella. And then we are expecting tokens. Yes, because I'm using this one a lot. Yeah. Expect tokens, so you're gonna yeah, just think I can just send line format like this. Which is not gonna be so let's get the closing parentheses. Then we're checking for the equals. And finally get our single value, which I guess it's just a word. So let's password token. Be coherent. Cool. So now we can actually push it in our tokens. Let's match it here. That's the word. So name. If we go var, if we got def 2, if we got internal 2, and if we got something else, it's unreachable. Okay, so that way we're getting our token type as expected or variable. Then we push oh yeah, it's got variable name already, so now we push the type. We can just push type directly. And then we push the value directly as an argument. Argument of value. Now let's put that actually pass type function to use. And it's not an option, it's gonna be a result. We getting, of course we get a token. That's the first thing we do here. Get the token, and then we put the error message string, and we either send the token type or we send a compiler error. And in this case, we already start with password token, but without a check. Without a check because we have these in reserved keywords. In all of the reserved keywords, we have all types, which of course they have not been much, but yeah, since there are words that are specific, you know, the same thing we're gonna put back var def in there, and I don't know, probably could make a let's put it as a better list. Which ones? Let's see if match if two. This we have. Yeah, let's put it. That way it's a bit more clear. I can start every line like this. And okay, perfect. That way it's a lot cleaner as a list, and we know that it's here. Let's see if it works. Okay. Oh yeah, we didn't finish. Unfinished pass type. Anyway, so here I'm getting the first of all I'm getting the word, which is gonna be pass word token. We do put a no check on there because this is one of the few times we actually go check for one of these directly, typically integer or string. And so token.error message. And then actually let's format it to be. And then we match the word string with and here we check for each one of them, and therefore here it's token type and it's let's put the word in. Then it's okay. Otherwise we send back single error. And format is gonna be an invalid type. Okay. So let's fix them. String compiler. Let's solve several one. Oh yeah, type is already called name. Type, definitely push it here, and this on expected string for reason string value. Yeah, we forgot to put that here. Actually, we also got that for all of these because this is not been tested. 5 errors. What's the problem? Yeah, true. Because we're using that every time, it's actually trying to move it because we expect it to its format. They just clone it every time. And that means we did pass a variable properly. That's new. Oh, hello, Hyperty. I take some time to read. So now that we got that, we got that through the Lexa. So variable name integer 200. Yeah, that's good. Now we got that through the Lexa. Let's get to the semantic part. And the thing is that now that when we pass a state, we're gonna have a little thing. Let's go back quickly to the whiteboard to explain what I mean in a cool way. So the thing is that in Castagne you got, of course, your state name, but some states are a bit special, and because we got few special cases. First of all, is character. That's the header. It does handle a bit differently. We won't really focus on it right now, or right here for now. Then we got variables. So either variables or variable, and then whatever. This is a variable block. And these are available on all of the character. Some variables can be inside of a state, like if I put a variable here, it will be specific to this state. This has some different rules, and we are gonna be able to do that when we get more on state calls and all of that stuff. And then we got, and we also got state name, the en for entity name, state name, and this one is it's for a subentity. And therefore we don't really match it for now. We're gonna check it out later. But at this moment, this is not for us. This is just for the. I mean, this means this doesn't work for the subentity just here. Okay. So now that so the idea here is that we want to pass on variables only here for now. We don't handle state variables, so just this. So when we get into a variables block, we just pass variables until we're good, and we'll export that elsewhere. It's still gonna be a state block because, well, why not? At this point, it's semantic state, and the semantic state can be a lot, so we're probably gonna put the semantic state type. Yeah. But yeah, let's continue. So the idea of how we're gonna do that is we're gonna get a stop at the. We're gonna get the script. We're gonna check in at the state script, of course. We can do that with only one look ahead character. So, oh yeah, I put that parse state function up. Okay, yeah. My bad. So, parse function. When we are here, the parse block, we don't parse the block, we parse in the parse state. Here, missing stop. Yeah, as you can see here, I'm parsing the block. So now we're gonna be matching with the state type. Before we do that, let's do it early. We probably want an enum. Semantic state type that can be. Let's call it regular for now. Maybe we will change that, but we might see it. But yeah, variables. And then we get our name as a string, and we will put a semantic state type. State dot state suppose type for name state dot name. And we'll return just to match name. For now, we're just keeping it simple. But here, that's where we will match all our state type. And we're gonna see what if we go to semantic. There we go. That's where we pass our block as usual. Otherwise, if we get the semantic state type of the variables, we're gonna be doing state variable. As you can see, we're also getting errors here with this, and we also got a state variable for one. But yeah, so we're gonna, as you can see here, we're gonna be adding immediately variables. What type is this? So we got our semantic elements, which have different types, but this is something that we want to actually translate, but variables are a bit different. Actually, can we just get the variable type immediately? Yeah. Yeah, we do. That's actually what we're going to do then. Do we have one on engine? We have one for engine because it's kind of part of the symbol table. Yeah, that's because what is here as a variable, that's actually just a hash map. That's our symbol table. That's yeah, actually, yeah, that's just that. Just a hash map. So let's see here. I think that's memory is the best place to put it because we got our memory entry here. We got the memory stack defined for us here, and we can just put the symbol table. So it's trying to find the symbol table, but we just create it right now. Symbol table is gonna have internally. It's gonna have the variables. That's just how it goes at times. Yeah, at this. Yeah, whatever. It's a bit overkill for what we're doing in the other one, but it's is it actually? Good question. Yeah, actually, let's not do that immediately. We're actually gonna use an intermediary type. Okay, maybe it might seem a bit wasteful, but we have metadata to keep with us, which we don't want inside of our engine call loop. So it's better to keep it separate. So instead of having a pub semantic element, let's put it here as a struct semantic variable. Because we don't want to know if a variable is static or not, constant or not at that point, because we will already be in it. Though we do want to know, but yeah. So that way here we can just keep the main, which is like a string, and we can because we don't have IDs and stuff, so let's keep it simple. We got value, which is memory entry. This also allows us to know the type of set variable, and yeah, that's it for now. We don't really need much else. We got the value, we got the type too in this one. So this is a hash map. Take the string, and we get a semantic variable from it. We need a name, maybe yes, maybe not. Let's keep it with it. Maybe not. You know what? We don't really good to have anyway. Yeah, that means we gotta keep the name and the string in sync, which is not really good. You're not obligated to do that, especially since a simple struct. But at this point, I'm gonna. I think it might. Yeah, we got all variables. A semantic state. Yeah, it's variable. Back new. Good. And then from that we can get the. I can get. We get I haven't been. I didn't start the timer when I started streaming. Let's because I was like, how many time is it here? Has it been? Uh, what does it say? With the it say I started at 10 a.m. Okay, or something. Let's put it here. Because I was like, am I getting good progress? Well, it's been an hour, so it's still expected. You got a lot of parts to have. So from our entity, we're getting. I lost my train of thought. Yeah. Yeah. Okay. Yeah. We are passing the variables. Let's continue. So instead of passing a block, we're gonna have a function pass variables. And it's it. We are getting a hash map of string semantic variable and a vector of compiler. Yeah. Cool. Let's remove those println. Let me put it workday. I don't want to say we all the time. Like yeah, like it's not like we both do the work, but I make the mistakes. But yeah, okay. So it's starting with semantic block, but we are in a state, so we don't care. We do want to get this. We do want to get get a new hash map. So let's continue. While is next? Okay, end of block. Yeah. We continue. Okay, so Next up, check if it's the correct token type. So if the statement we got a match for a variable, we're gonna put it into a parse variable function. Because it's tricky enough as is, you know. Did I put parse function? Yeah, I put parse function. Result. Okay, of course the problem here is that if we insert something, we first need to get the entry. Like if we have, we need to check if it is inside of it already. Because if we have two variables that have the same name, we want to raise the error as soon as possible. That's not an issue here because we don't have between two variables, but here we have just one, so we already know that we're gonna have trouble. It's not because if we got a variable name in one block and the same in another block, sometimes they can overwrite each other. But here we're in the same block, so we can expect the guy to at least know he's not doing anything. Okay. So we got the P damage. What was the contains key? I believe that we will have to refactor slightly, but and if it's not, do a bit different prefer with something. If the key is present or not, I guess we could do that with the entry API. However, it's a bit more complicated. I don't really know yet how to do that in a proper way. We could learn. Because we actually kind of want to do that here. Yeah, kind of mess here, let's be honest. Yeah, let's just leave it all the way. So if we don't match with if the that doesn't match the variable, we singular. Wait, no, because there could be comments. Right. Come on. Yeah. Okay, so we do need to pause this, but we kind of don't need to do anything here. Oh, that's a bit sloppy, but we're gonna work through it. Let's give back an okay like this. No, probably not a string we want. It's probably a Castagne. Whatever. Contains keys. Are we good? No, 10 errors. Okay. The result's probably a bit small. Let's see if I can put it up on the second screen to have the experience be a bit nicer to you too, so we don't have to watch every spelling mistake I made. Okay, semantic. 929. Up. Ah, there's too many warnings. I definitely need to stop them at some point, but just because they're becoming annoying. But but that's still early development, so that's why we have many of them. I'm not removing them because otherwise I would forget to re-enable them. Others? Yeah, that's let's see next. Mismatch type. I need about. Oh yeah, no, it was having an issue because let's go back to the semantic file. 29. Oh, yeah, so it's also missing the this and we got Oh yeah, and doesn't have a name field in the end. Let's put back the name field. We have our name field, folks. Variable dot no, I forgot to send back the mistakes potentially. So okay. So there's errors that take, they didn't handle. So passing like 95 here, C variable.name, because it could also not pass that, but if we have issues with that, we will actually, we won't do that, we will continue. Already less errors. Let's see then expected hash map, and if it the result on a single error, 98. Okay. Oh yeah. Yeah, because we're actually not returning that single error. Yeah, but we are. But we will be maybe returning that vector of errors as an error to the statement. That way, so all of this here. I mean, that's kind of actually that's not too bad that we got it here. You know what's that? That's a function. That's a function that we are pass variable to list. So we're gonna be having a which is a hash map of of a string and semantic variable, and which returns of course a result of. Okay, we're gonna switch that up quite soon, but whatever. And the vector of compiler. Oh, you can see here let variable pass variable. And if it doesn't work, we just do this, which means we can keep all of that. We make our code easier to write with return. Now that we are not using, we don't have to scramble to make that into one return only, we can do all of our error management here and insert it here, which means that this line becomes just tokens, but we could put variable. This gives us this should already compile better. Well, 2 errors. But yeah, so there's one I still forgot to pass, which is just this. And then mismatch type. Parse variables expect something, but it's we're returning something that's not what we want to. Yeah, because we are forgetting variables errors. We're compiling. It's technically, so fellas, at the moment it is working, but we don't really want that. I mean, we have that. We're gonna have that issue for a bit, but because it's actually using the names we have. Let's just break the test right now before we forget, and have that as objective. We got it in mod. You see here, because we have the memory stack and we have hard-coded the values, this works here. But if we put the e variable, now the test will fail. Because it's not handles symbols properly, because it doesn't know about e. So of course it won't compile at the moment. Let's also, I mean, that's not valid Castagne code, but it's gonna be what we need. So variable e integer equals 2 0 0 a b c d e. That way, it's supposed to handle it after that, but we will have to use a symbol table, that proper symbol table, and use that symbol table to get the variable ID for C. And I mean, I guess it kind of worked without, but actually, let's make it annoying for us to work. If it's gonna work, it's gonna be complete. I mean, except the fact that character is not treated properly and we don't have an initial state, but each thing in its own time. We'll get to it when we do state transitions. One fail, yeah. So it doesn't know about it, but go check. Okay, we're compiling this. Okay. So, because of course this is what actually does that, and it won't work until we get this probably done. But yeah, let's pass a variable. Now that we have all of this, let's actually pass that variable. Or we won't get anywhere. But we are actually pretty not that far away from managing to implement variables into this compiler. So let's remember the Lexer said that we got our tokens like this variable type argument. Okay. So the thing is, I'm gonna right. So the thing is that we don't have. Can we match with just the type of the inner? Yeah, well, okay, that's the match, but and I guess we don't really care if let même discriminant. Well, I guess we're gonna use the matches here. That's you're gonna have to handle it on a at this point anyway. Like, yeah, actually, we don't have much. Let's we're gonna have some trouble when we pass two variables, but let's see. Oh, how do we do that? So in matching that token. Pass. At this point, we already know we got a variable. We have an expect token or something with a function. Oh, what's our expect token function here? Token but from whereas the whereas we're in our Alexa, it kind of does something else. The expect token, right? Just I have it got an option and we got an expected for a specific one. Yeah, matching. On toilet break. I'm going back in just after that. As AFK for a few minutes. back where we go. Okay, so let's continue here. So we're expecting that. Yeah, we said expecting a token. In practice, we'll have to we'll expect we'll pass it properly like we do here. Here, expecting a variable. Its variable name, the variables are varied. Then, yeah, I'm running properly. So after that, we're expecting the type. Expected, call that type token. Yeah. Okay, so with this, it's type as a string. It's not the best error for the user, but he'll adapt. Of course, here, yeah. Hey, Colmeric. Yeah, so we're expecting, here we're passing our variables. Let's so, of course, back to the whiteboard. We're gonna, we're trying to get one of this format, var, which can be either defined or an internal variable, the name, the type of the variable, some metadata, which we don't use yet, equals value. We already lexed it to other tokens, which gives it to us in this form of a variable, a token type for a variable, one for a type and one for an argument. These are strings as of now. So therefore, in our second parsing step, we actually transform. We're finally getting them after reporting all the errors and variable and blocks and stuff. We're just gonna do. We're getting this, the variable name, the type string, and the value string, and we're gonna transform it into a memory entry and see if it's the same type indeed. Well, at this moment, we only have integers, so we'll do a small shortcut. We'll use the match syntax here, therefore, so that we are certain that when we have to go back to it, when we have other string types, it will catch it here. So since we have an int, that means is memory. We're gonna return a memory entry. And here we're taking the args as an int32. I think this is the syntax, but at this moment we don't handle the mistake if it doesn't work. So let's let's actually just do that and match it properly. Since we do return a result, so either this variable or the compiler error. So we're trying to do an int, and here we match this. If it's okay, we send back value. Let's do it here. It's gonna be easier to see. And if we don't, we're gonna send back a single error, which is our helper function, and format it. So this should give us the variable. Okay, semantic variable new. And we're gonna send it both the name and this value we just added. I think I added this later, so it's slightly wrong. Yeah, we also need the name. This should work. Few mistakes. Expected string got str needs a string. And this is want to be type memory entry, and this is okay. Yeah. We forgot to return that. This gives us only one mistake remaining. Enough. Yeah. Okay, cool. The test of course still doesn't run, but we did manage. No, we did get a few compiler errors back out. It expects an argument token, but he didn't get one. So it's for each of our variables. So A, B, that. So why didn't we get an argument token? Because it's we forgot about that. Okay, handle symbols properly. What didn't it like? Oh yeah, handle symbols properly. That's because our symbol table is still hard-coded at this point. So this test is actually a full test with a state given here that is supposed to add two variables together. But at this moment, it doesn't know, because we don't have a symbol table yet. The memory addresses are hard-coded into the VM. So now that we have finished parsing everything and we got our semantic states, we're gonna get our variables inside of the compiling step. So of course it was in our semantic representation. So when we did the register symbols, that's what we actually want to do here. So we're gonna get our variables there. In fact, no, it's even it's just gonna be the symbol table in general, and we're gonna finally get that symbol table. Maybe the symbol table, maybe not the correct thing, because we are only do that for memory. So memory table, and we're gonna create. We're gonna have one first new method. Yes. From semantic variables. And this point we can just send it a vector. Vector of semantic variable, which will translate it to some IDs, and then for each of these IDs, we're gonna build a hash map that will give us the ID for that. So map, we give it a variable name, and we get back its memory address. And yeah, I think that's pretty much what this this function is. Table. Though we should get the values too, which is gonna be a vector of memory entry. So this is what we're actually getting from the semantic variables here, and from that we will be and then we will have to get the memory stack, which is what actually holds all these memory entries. We're just gonna make a function from table see. This is gonna give us an empty memory table. We're gonna implement that immediately after. And this from table, that means that first of all, we're gonna have a memory stack. That's getting so the table is equals to C, which is a reference counted pointer table, and then vector memory table. I'm used to having vector everywhere now. And the entries are going to be a table dot values dot clone. Just straight up clone of that. Get the empty constructor. And from our semantic variables here, we're gonna iterate on every one of these. There. Let's get just a reference tab. And with that, we will do for each one of them, we're going to enumerate this one, which will give us the IDs at the same time. We don't really care about the order at this point in time. Just wanted to get it working. So we're gonna push v dot value dot clone, and in symbols insert. At this point, we know that there's no collision, although we could check for it later. It's not really an issue, but I think the compiler already catches it later. So symbols insert the name of the variable with its ID. That way we can go back to the yeah, from that we are able then to use that memory table to fetch whatever values we need when we will actually need the character state translation. So okay, so I think that's good. Let's make another function. Let's get with the with our symbol. Right. Yeah, I think that's a good name. String. And we make an option, which means it can be null or not of. But get ID from symbol. That's best. So either usize or well, let's here. So here, what we do, about self dot symbols entry. I do need to check once again the docs for this for the entry API because it that was the or insert, but that's not exactly what I want to do. Does it have just the or default? Yeah, no, that's not what I want. I will just use contains key. Contains key symbol returning this one properly, otherwise returning none. Well, actually, I'm stupid. That's so common. It's actually just symbols.get. And we are good. And here that means it's a memory table. We only have one at this point. We might have several ones where we got several entities per file, but at this moment in time, it's correct. So here we're gonna go for each one of our states. And we're gonna match for the type of that state. So if the state if it's variables state type, if it's one of our state that only holds variables, we will create a symbol table from that. Otherwise, we won't. We create a vector to store all of these variables. So it's actually just 13. That way we can have several, we can handle the control flow better. Here we got so state variables. And then for each of our variables, we are going to, well, check if it already exists or not. We want to check for collisions, not yet. Because this is going to be more complex behavior of different states and how they all relate to each other. But so at the moment we only and in any case we only have one state. We have only have one variable static state, so we can just actually just put append state variables. Can I get the values directly, or do I need to values? Okay, so that just remove values here. So visiting all values in arbitrary order. Can I collect them directly? 12 hours, that's new. Oh yeah, because we don't have all of these. Okay, so in memory, it's not returning a memory table at the end of from semantic variables. Let's solve that immediately. That yet, so it doesn't know the S type field state, because we did this one's not that weird, because we do get state type here. Oh yeah, but the type is string and seven. Oh yeah, because I didn't iterate properly. Yes. Because state is a hash map, so it's this is a state name. I guess we can go with the values here. Yeah. So tell me that. Okay, so first of all, memory table doesn't exist yet. We didn't import it. That's for the. It's probably. And we also don't. We didn't give it here. Was table. That's one thing, and the other one's gonna. Because it's not a more errors. Okay, we can't build the vector, but are we getting some memory table? After this, we only need to access it during the rest of the steps, and we'll be good. I'm not using the hash map, that's why it doesn't know about it. And ERC in memory. But here we need to dereference the value. The reference ID because user is copied on the stack. Declare type. What do you mean it's not accessible? it's public, but I guess the module isn't public. Okay, I understand a bit better. We're just gonna make it accessible, not the module, but the memory table. Memory table is accessible from there. Already solves a lot of errors, but we still got some in memory. Actually, even there, instead of constructing it like so, yeah, I think I don't want the engine to rely on the compiler to work. So I'm actually going to move this function inside of the semantic which will make it easier here. We're gonna get gonna have another so of course it's gonna have string and get the value as a memory entry. It's gonna be so how many values do we have? The length. And then we're gonna push that value. Push. And we are gonna insert our ID. To string actually. And insert that ID. Perfect. And then for on semantic here, we're gonna probably want to do that collision check. But for now, it's okay. Here's a little. We don't need the enumeration anymore. So we just iterate on a vector and we push. So this is one, we're not modifying it, so we're just gonna push for everyone. So table push add variable with v.name string v.value, and we just return the memory table at the end. In this case, we're also moving that to be this. Yeah, I think that here that's this one's gonna consume the variables if I or just the iterator. It's does that work? Let's see. 6 errors, so I guess that's stable. Let's do it Let's do it this way and be done with it. With that closure. Or anyway, get adoption size back here. Okay, so you can't find values. Okay, so closure. I was thinking that collect would work, but I guess collect maybe a bit above my skill level with the language at the moment. Self. One L. Vector of. Okay, so I'm saying a reference to semantic variable, which is not what we want to do. But if I'm cloning it, I'm getting this. That occurs. Oh, it doesn't have clone at all. Okay. So it's actually calling clone on this on the reference, not on the reference type, not on the actual semantic variable, because I. Okay. Okay, so cool. We compiled. We got those state table. Now the only step left is to actually give it to the compilation step. Here with compile state. Because a semantic state does have a memory table associated with the state or not? Can we pass it through here? I think that's the because because everyone kind of needs that, because in some cases we might overwrite it with a local variable, so therefore every state has its own memory table for that semantics. And of course here that can be another one, so we just use an RC so that we don't need to clone a memory table every time. We can just refer to the same one, which is a bit better for memory and not too hard for us. And compilation. Let's even do it here. Yeah. As a new RC. Let's put it as an RC inside of it. To actually start it with. RC does imply that we can't modify it without using a ref cell or whatever. We're not using a ref cell on this one because we are going to either clone the RC or clone the contents if we want to change the state. So each state dot table self dot memory table clone, and the compilation can continue open. Let's see if we have errors, because of course we do. We didn't import RC. Missing the memory table from the semantic state. Okay. Of course we did. We could make it so that we don't necessarily have one, but let's keep it like this. Okay, so we did get, now we got that semantic state through. We are going to compile or block, but that block will need a memory table, otherwise it can't actually compile the function without its memory table. Let's see if I can, I forgot the type exactly. Let's see with RC. Do we have to do anything to get it? I think not. I think we can just get it directly. Let's see if it compiled. It compiled, so that means it was the right call. So once we have a memory table like so, we can just pass it again to function. Because this is where we actually need it. Because here, we're gonna do a little match between argument to customer. So of course we didn't actually, because that argument could be static. Because at this point we just have a string. So it could be a static argument, it could be a variable argument. But at this moment we only have variables and we don't do constants. Like even though the VM can handle it, we don't have any constants because we don't pass the constants. If you want to do a constant, you declare a new variable, but you know, that's how we get actually to improve performance later and say it was planned all along. Oh, that's what we do. Oh, not from symbol argument. And if we match some and we got our ID, well, we send back okay. That's open. And we give it that ID. Or if it's none, we return a compiler error. We're gonna add that type in just a minute. We're gonna check real quick in the compiler to add set function. Population error is actually the better name. It errors. Oh, but we forgot to actually pass. we forgot to actually pass that the memory table. Ah, okay. Okay, so that means we actually got up to there, but we don't have the correct value for whatever reason. For whatever reason. But let's actually just, let's analyze our symbol table inside of the compiler. Yeah? Oh yeah, because we didn't actually get the correct. I think the test is still incomplete because we cannot call it, state table. We get it like this, but we do set up the memory. We set up the memory wrong here. Yeah, that's uh, that's why we have an issue. We didn't set it up properly. Of course, we were gonna have problems. So we get a memory table 2 here. A memory stack from the memory table. Otherwise, we cannot don't get anything. So, but of course here we don't get we have the compiler, and to set up the engine we have to do sr dot. Yes, I get memory table. Let's do it here as a function. State. Reference it and then clone that memory table. And memory table can be cloned. We'll fix that real quick. Build fail for one error. One thing. What's going on? Why does it have that many? This one's just wrong. Because it's from memory table. We actually want a reference to that. Here, and we plant it. Guess I could use the R system, but yeah. So we got the memory table. That wasn't it, but that was still needed. We're gonna check why the test doesn't run. By actually, you're gonna print or you're gonna get memory stack here and print it properly. Did I put debug just before? A is 1, C is 2, D is 4. Yeah, so we did get them in an arbitrary order, which is why we actually don't, because yeah, look, because we cannot get we get a hard-coded memory value in the test, if you remember, which is why it doesn't work, because it doesn't do it in order at all, which was expected somewhat. But yeah, you see here, own, that kind of doesn't work. So what we're gonna do here is so even though, well, why do we even do that? Let's just still keep it as an RC, because we can, that's just the only thing we need, let's be quite honest. We just need the RC type, which will be properly. We're gonna still need that one. And in the memory here, instead of base. I think that's gonna work. Yeah, it's missing that argument. So but symbol, we are looking for C, F. We are looking for F. E, E, F. Work. Expected use side. And the test works, because I mean that's what he was gonna do. Because yeah, I mean, now that we did see the memory table did work as expected, therefore we got variables in Castagne now. I mean, we did already, but the new Castagne, you get what I'm saying. Uh, yeah. So let's see what's the next step. What's the next stage? So now that we got variables, we got variables. We got now. If you remember, in the yesterday I said that that was the first step. Second step is gonna be functions and validation. Because I'm a bit tired from all of that. It's not been that much, you know. We still get some water. Get some water. And now it's time to validate our functions. So we add and then declare stuff. So module's gonna happen on the end of the week. The core one will be everything. Branches will happen just after that. We do need that jump instruction, which will require us to be able to get some reference to lines, like every line knows its ID of sorts, which is, I mean, it's not that bad, let's be honest. We can figure it out by, yeah, it's not gonna be too hard, of course, because we only jump for branches. And but that will change, or that will change the runner. Multi-file support, that's gonna be annoying. Let's hope to not do that today. I don't want to do that today. Okay, so now the next step is of functions and validations. So we got, of course, so in our functions, we got this idea. So we got the function name, and we got the arguments. But the idea is that here at the moment we just kind of assume, everything's working as expected. We just have a specific number of arguments, and we never test neither type nor nor value. So next idea is next thing. Yeah, it's gonna be, well, let's test these out with a specific from a specific list, because we also could write add A, B, and nothing else. With the idea is that this gets internally translated to add A, B, C, A, B, A, sorry. So it's the same idea. Some functions are a bit more complex, but you can see here there's a sort of default value, which is gonna be here, and we don't check type. This can be either either an integer or a variable. So we're gonna need to get some argument types real quick, or we're never gonna get out of there. Because while cast vars are nice, that's what we get to compile. That's still a bit tricky. So what we're gonna do is now we're gonna change our function definition. First of all, function list will start to get with name, like we got the function name that will be able to access it. But especially we're gonna have another function here to actually pass that. And so this is what we're gonna do is we're gonna start simple instead of trying to handle both of these right now, which, I mean, yeah, we kinda will have to, but let's first get full branch with the types, which we're not gonna type out today, but so it will be variables for a bit. But this way we will actually check for types using our memory entry. Yeah, I kinda notice I neither need to check type or to check number of arguments immediately. But the thing is that we'll have a sort of matching function inside. Like when we get our casp function, we will first get it through the validation function. This function tells us if this argument list is valid for the function, because we know that we are calling the function because it's its correct name. And if it does, then we send out the parse function that might be specific for this arguments here. But because, yeah, the thing is that that means that one cast function can have several parse functions. And with it, so that for instance here, oh yeah, I've got ABC. Then if I only got AB, I just add this. Well, that's kinda simple, you know, but that's not really the point. We could allow it to match on less values and still return the same function. We could find a way to put some defaults in that, but that's not really. I mean, default here with that structure is a bit tricky, ain't it? Because we do want to get like we do want both the type and the other one. And the thing is that memory entries have a type, but maybe we want to make a new enum, which means that types are going to be duplicated. But that could decorrelate the internal type from the actual type, which could be nice, could be not. As you can see, it is a bit tricky, but that still doesn't give us the idea if it's a default or not. But yeah. So what we are gonna do is gonna actually give two lists. We're gonna give it one list here, because the idea is also we think of how, because we're gonna have to declare many functions, we don't want to spend forever in each one. So the idea is that here we want to give it a list of types. And this length gives us the exact. This gives us the, or well, it gives us the number of arguments and their types. Up to now, all good. Then, but on another issue could be to maybe we also want to have we could get several lists to get all the arguments, so several lists of types, or maybe we get a default, a list of defaults which are options for types. Oh yeah. Actually, yeah, we do want to have several things, because here, I mean, it could be A, B, C, or be A, B only. But as you remember, maybe, the thing is that every one of these values, so because we got the type, but we also might want for that same type, that also might be a variable or a constant, a variable name or a constant. And this doesn't really give us much. It's because yeah, we want to be able to do add a1 with so that one is a constant which can be coerced from type integer, but we don't want it to come. So the type is gonna be separate. Oh, this is gonna be a bit annoying to write. Let's put I think I can put a marker on the stream for for that. So because it's a variable name, but can it stay? Not yet. Because that's why that parse argument stuff is gonna be real interesting. Gonna make our arguments more complicated, but we kind of need to bite the bullet, so we'll do it now. Because yeah, up to now we have 0 type inference, and we will need to do that type inference. For that moment, let's ignore defaults. Let's ignore defaults. Let's ignore the several element types. Let's just get one list of types. So therefore, we do need arguments to pass. So an argument when we read it, it can either be var name constant, but when we parse it, we might get an expected type, because we can figure it out, kinda. But it is better if we have an expected type, because otherwise, how do we handle a number from something else? How do we, if it's a strict string? Therefore, because we might look for a variable, but we're looking for a state name and stuff. So if we don't have any information, that's hard to say. But that's why when we pass an argument from now on, we're actually doing it in the semantic, I guess, here. I'm trying to think. Because yeah, we want to, because in the because the lexer gives us correct lines in theory, while then when we get to that semantic, then we pass it into the list of variables and stuff, so we know that we got variables. And then now on the compilation step, that's where we can actually validate. So that's the proper place to validate all of that. Argument to caskvar, that's a good one, but that's the function we want to, and we want that expected type. We do want, however, to have a bit higher level function, which is gonna be our semantic type, I guess, for the variable. Oh, I got it. Check this out. I got it. Semantic type, it's gonna be an int. Gonna be instead of whatever. And then it gets an option of memory entry. We're gonna suppose the memory entry is correct, but that means that now when we do a semantic type, we can have this as a default value inside of the semantic type, which in most cases, we might not care about this. But if every one of these semantic types has an int or as a potential default, that means we can take it as a list. And so we can do int, because if you remember, the thing is that we also have a specific type which is variable, which is not a type here. It's not a type on our system, which probably won't be. But that means we can still, the fact that we separate these allows us to make more, to make funkier types, funkier elements inside of the semantic representation. So for instance, the semantic variable does have that memory entry, but we didn't put in the type. I don't know what I would put in here, but because here we actually have two types, because that's actually our function definition for add is int variable. That's the trick, because the idea is that we take a plus b and we put that in C, so we can't put that in a constant, right? So we do need it to specifically be a variable. Oh, of course here that's not a memory entry, so that's a bit tricky to get. Like, for instance, here, let's be honest, in that case, I can when I do A, B, I want A plus B and to put it into C, which is going to be a variable. That means that this this function signature is different. This one's a var int. Never really paid attention to that actually. So we're not actually using defaults for this one. This one we're not using defaults. We're using two distinct functions. So two distinct functions here. It's with our same times we do var and int with no defaults, so both are none. None. It's none. It's also int, none, and variable none. And this gives us two lists to actually match against in which we can then feed to other validation function. So that's great. Say it actually. Therefore, I'm trying to think a bit, but no, that's we do. We're gonna have to implement those types and values and all that. Let's make a quick let's say implement in semantic type. Might as well. That's so one first function we get for semantic type is type name from type name. This is gonna send back a semantic type. Actually, more an option of semantic type if we did find one. We're matching this int. We're getting back type int. This is gonna be like a bit of a drag to write, so let's make this here and make abuse with the st. Oh, it's gonna be easier to write, and nobody's gonna actually come here. So st int none. So you might remember we actually did that somewhere just before. And that's gonna be our ticket here for the semantic variable, because we did get this one with the memory entry here. Let's put it here, semantic type. Because maybe the value is gonna be a semantic type too, but yeah. I'm gonna check detail. I'm gonna see how it goes over time. Don't think this one's correct, but let's keep it that way for now. Yeah, so when we create our semantic variable, let's look for it as well. So in this case, we're not in this file. It's in the parsing file, I think. As a variable. Yeah, look. Yeah. Yeah, no, that's actually us what we want here. So all semantic type from type name type string else, and then we return our singular. So now we got the type here. Then we do need, in this case here for our parse variable, we do need to pass value as type, like the actual low level parse it. Without the default, we don't care about the default. It's gonna be this is an actual value, and we know this one's gonna be a memory entry at any point. So if we don't, we of course return a single error. Wait, actually, because it can send back an error for us. Okay. That immediately actually. But yeah. That and the function, how did we call it? Pass value. Pass value be a result of either I think we send a vector, so we can't really coerce it like this, but we will just do it as memory entry and compiler error. Oh, no. Put it as a it's a result, definitely a result, but we might not want to get that compiler error. But just there's not even need an error. We just need to say that we got an error. We don't need to actually create one. So let's match, because this is a self. Match self if it's an st int. That's what we do. For the rest it's to do, because we don't want to pass the variables immediately now. So let's see. So got the type, got the out semantic, yeah, pass value. And there we're gonna actually take the one we had in compilation, parsing, yeah, value string. If we got it here, it's literally the same function. I could have just pasted it like so. Send it back and okay. And if we don't, it's an error. We don't care which, so we're not sending anyone. Okay, so pass value, and if we don't, we just return that single error here. So this pointed variable, yeah, getting message is probably gonna have to. We're gonna eat earlier than 4 p.m. this time. So Probably gonna have to end stream early to actually get some food for once. A rare one of my eating at regular hours. Not so much regular. Let's see. Let's finish this quickly. So we pass the value. Get and therefore in our compilation part we do have the passing part. We have the where did it go? I forgot where I was. Probably look stupid in replay. Parse variable here, parse single variable here. Okay, it doesn't look anything like what it did before. That's why I couldn't see it anymore. Okay, let's send the type here. Should actually compile. Okay. From type name. Okay. Popular URLs. Okay, so I didn't write it properly. And we're gonna back up with semantic. From type name, option semantic type. Okay, so sum is here. It's here. That should be good. Here. What's the error? Wait, I don't understand. Unexpected comma in pattern. I don't get it. I'm not matching on a tuple, it's just an option of semantic type. So I am sending back some or none. Is it a semantic type? Oh, I forgot the pattern, of course. Of course. Then here doesn't see bars. So this find here in str, why does it can it pass? Actually, that's I don't know. It's value s there. Value this once, okay. But the idea now is in the parsing file. I use type, which is a reserved keyword. Same type. And give same type here. Whatever. Which one's the last one? But here. Okay, so now the test fails. Why does it fail? That's a new question. The values here. So I'm getting 0, 1, 2, 2. That's proper actually. So I am getting these. F is oh wait, no, it's not in order. A is 4. Okay. D is 5. That's the last one. B is 1, 3, C is 2. Okay. Was a bit less selected. Lastly, think what's going wrong here, because the only thing we did change was the value. We're not returning a single error. Otherwise, we would have had, we would have panicked before. But here we don't, which means it did pass properly. And that means maybe, oh, memory address translation is not correct. Because E is 0. Can I print my state table too? That's gonna be can it debug? I can't. Let's put it back on that. Where do we have the state table? That's an excellent question. It's not implemented for cast command. Well, that's for 2. Okay. Add 0 to 1. Nope. Address translations working expected. Seeing because B is 2, E is 0, and F is 1. So we actually do we actually are doing this properly. We should print the memory stack at the end to see that if everything's working properly. Of course, this doesn't work with bigger memory stacks because of good luck. Good luck with that, but from the state handle, what do we get from the state handle? Let me get hungry. State handle, it's got the entity. Oh, but we get the memory stack. Oh, yeah, because I'm borrowing the entity to get that. It's a mess. Critical path. I don't like it. But yeah. I just do it like this so I can. Yeah, okay. Cool. We got the left cell for our memory stack. Memory table, still got the same memory table, don't like it's changed. Of course, of the symbols moved around. We love this. For F. And there we have a problem. No, wait. But the symbol and the values here, but the entries here. Yeah, the issue is that it didn't actually set anything, which it used to do. Why doesn't it do that? It's supposed to execute, and it did execute before. And it's not like the types are actually Same. So that probably means that we had an earlier bug. Okay, but yeah, I can't really think about it, and this gonna require some time. So maybe stream again or not. I think I might not have the time to today. But yeah, we definitely did some progress today well, we got. Well, I was gonna say we got that variable parsing. At least that's done. But it should work. Maybe it worked. Maybe it doesn't. We'll see another time. Okay, well, and then see you around, fellas, and have a nice time, a nice day. Bye.